Good morning, student. The next problem, number 12 from the current electricity lesson. Determine the current following through the galvanometer, capital G, as shown in the figure. Now, the solution is apply Kirchhoff's current rule at junction P. Here, junction P. So this is the 2 ampere I current I enter to the junction P, then I1 and I2 leaving from the junction. So what is the first rule for Kirchhoff law current, otherwise called current rule? Current entering to the junction is equal to the current leaving from the junction. Algebraic sum of the current meeting at any junction in a circuit is 0. That is the rule for the Kirchhoff law, first law. Algebraic sum of the current meeting at any junction in a circuit is 0. So entering towards to the junction become a positive. Leaving from the junction current become a negative sign. Here junction P, there are 3 current. One is the I current, 2 ampere I entering to the junction. Then I1 and I2, both the current are leaving from the junction or away from the junction. Here the equation can be written as I, that means current enter to the junction, it becomes positive sign, I minus I1 because leaving from the junction, then minus I2, the I2 current also leaving from the junction. That is why we put minus sign for the I2 current. Minus I2 is equal to 0 because algebraic sum of the current meeting at any junction in a circuit is equal to 0. Now rearrange this equation. I minus I1 is equal to I2. This is the first equation. Next, apply Kirchhoff's voltage rule for closed path. So what is the rule for Kirchhoff's second law? Algebraic sum of the product of the resistance and the current is equal to the algebraic sum of the EMF in the closed circuit. Here we can consider the closed circuit path is PQSP. Here PQSP. Here the product of the resistance and current is clockwise direction means become a positive, anti-clockwise direction means become a negative. Here clockwise direction current is I1 and IG. Then anti-clockwise direction current is I2. So algebraic sum of the product of the resistance and the current. Now the path, closed path is PQSP. Phi I1, product of the resistance and the current, phi I1 plus 10 Ig minus 15 I2. Here this equation, phi I1 plus 10 Ig minus 15 I2, because this is 15 I2 minus 15 I2 is nothing but anti-clockwise direction of current. So phi I1 plus 10 Ig minus 15 I2 is equal to 0. Already you know the value for I2 here. Just substituting the value of I2 through this equation, we obtained from equation 1 phi I1 plus 10 Ig minus 15 I2 can be written as I minus I1 is equal to 0. Now multiply this term, we get phi I1 plus 10 Ig minus 15 into I 15I minus and minus plus 15I1 plus 15I1 is equal to 0. Already we know the value of for current I is nothing but 2 ampere. Here substituting the value of I 2 ampere 2. So here 15I1 plus 5I1 is nothing but 20I1 plus 10Ig minus 15 into, what is the value of I? 2. 15 into 2, 30. So the 30 term moves to the right hand side, means plus 30. Now the equation can be written as 20I1 plus 10IG is equal to 30. This is the equation number 2. Then the next step is apply Kirchhoff's voltage rule for closed path QRSQ. QRSQ. So this is the closed path QRSQ. Now the equation, product of the resistance and current, 10 I1 minus Ig, 10 into I1 minus Ig, then 20 I2 plus Ig, then minus 10 Ig. So the equation is 10 I1 minus Ig minus 20 I2 plus Ig minus 10 Ig, because minus 10 Ig is the anti-clockwise direction. So that is why you can write minus 10 Ig is equal to 0. Now the equation is 10 into I1, 10 I1 minus 10 into Ig, 10 Ig minus 20 I2 minus into plus minus 20 Ig minus 10 Ig is equal to 0. Here minus 10 Ig minus 20 Ig minus 10 Ig. So 20 plus 10 minus 30 Ig minus 30 minus 10 Ig minus 40 Ig. So 10 I1 minus 40 Ig minus 20. I2 can be written as from the equation 1, I minus I1. So 20 into I minus I1 is equal to 0. Here the small error, here this mention closed path is QRSQ. It is not a P. QRSQ. This is a small error. QRSQ, closed path. From this closed path, the equation is 10 I1 minus 40 Ig minus 20 into I minus I1 is equal to 0. Here multiple this term, we can get 10 I1 minus 40 Ig minus 20 into I minus 20 I minus into minus plus 20 into I1, 20 I1 is equal to 0. Now already we know the value of I. I is nothing but 2 ampere. So here 10 I1 plus 30 I1 is nothing but 20 I1 is nothing but 10 I1 plus 20 I1 is nothing but 30 I1. 30 I1 minus 40 Ig minus 20 into I value is 2. 20 into 2, 40. This minus 40 goes to right hand side. It will become positive. So 30 I1 minus 40 Ig is equal to plus 40. This is the equation number 3. So equation 2 and 3. Equation 2 can be multiplied by 3. So 20 into 3 is nothing but 60 I1. 10 into 3, 30 Ig is equal to 30 into 3, 90. The third equation multiplied by 2. So 30 into 2, 60 I1. 40 into 2, 80 Ig. 40 into 2, 80. So cancel to each other. 60 I1, 60 I1 cancel. The next, subtract these two equations. Minus into minus plus. So here minus from the second equation to third equation. Here minus in minus plus. 80 plus 30 Ig is nothing but 110 Ig is equal to 90 minus 80, 10. 0, 0 cancel. So 11 Ig is equal to 1. Ig is equal to 1 by 11 ampere. So the question is, determine the current flowing through the galvanometer. Here the current flowing through the galvanometer, Ig is equal to 1 by 11 ampere. Thank you.